Hi folks, welcome back to 6.2 Disc and Washer Method Practice. In this video we're going to take a look at question number 3. Question number 3 says to find the volume of a solid of revolution generated by rotating the regions bounded by f of x equals x squared, y equals 0, and x equals 2 around the x-axis. Alright, so like before, let's start off with some pictures. So let's start off with our f of x equals x squared. And I can plot those points pretty quickly, 0, 0, 1, 1, and 2, 4. And I'm going to go ahead and connect those points. Okay. Alright, so what about the blue line? It says y equals 0. So this is y equals 0. So this is sort of the bottom of the region that we're revolving. And where are we stopping? Well, we're stopping at x equals 2, which is this line right here. Okay? So the region that I am revolving is the region inside of the pink and purple and blue. And we are revolving this around the x-axis. So our axis of revolution is y equals 0. All right, so let's draw our reflection to give us an idea of what this shape looks like in 3 dimensions. Okay, so we have something kind of like that. And we know that when we revolve, we're going to get cross sections that are circles, and that the area of a circle is pi r squared. And so on our diagram, we want to draw the radius of each circle. So I would have like this would be a radius, this would be a radius, this tiny one would be a radius. Okay? So those 3 blue lines represent 3 example radii in our shape. Okay, so now let's set up our integral. Well, volume equals the integral of area, and my blue lines are perpendicular to my axis of revolution, so I'm going to say dx. Well, where are my bounds? I'm starting at 0 and I'm finishing at an x value of 2. I need the pi, and my radius is given by the function x squared. Now this radius needs to be squared because the formula is pi radius squared. Okay, let's simplify. Pi, the integral from 0 to 2 of x to the 4th dx. All right, let's take our antiderivatives. 1/5 x to the 5th, plugging in 2 and plugging in 0. 1/5 times 2 to the 5th minus pi times 1/5 times 0 to the 5th. This last term goes to 0. And what do we have left? 2 to the 5th is 32, so I have 32 pi over 5 as my final answer. All right, so in a nutshell, here's question number 3. All right, we're going to stop here for this video. Come on back for question number 4. See you there.